okay? So don't forget, we have this process that starts with simplifying. And remember, that's either the distributive property or combining like terms. We then move on to isolating. And that means getting the variable term away from the constant term. And that usually means that we're adding or subtracting terms to get that accomplished. And then our final step is the solving. So the solving is when we ultimately get to the final point of getting the variable equal to whatever the solution is. And that's usually done with multiplying or dividing. So these are the three steps that we walked through today. And we're going to take them in this exact order. And just as a reminder, this three-step process will hold true for any equation that we try to solve. But if we happen to not need a step, we just move on to the next. So when we're solving one-step equations, there was no simplifying to do, there was no isolating to do. So we just moved on to the inverse operation process to finish solving. In a two-step equation, there was isolating that was necessary before we moved on. And now with any multi-step equation, there will be some level of simplifying, either by way of only distributing or only combining like terms, or both. And remember, if we have to do both, the distributing property comes first because that's multiplying, and combining like terms comes second because that's adding, because the order of operations makes us go in that order with the operations. So let's get started. Now remember, we can look at these equations as being one expression is equal to a second expression on the other side. One expression on the left is equal to a second expression on the right. So we'll take liberties to do all the simplifying that we can do. So when starting that, let's see if there's any opportunities to distribute on either side. Well, I can clearly see on the left, there's parentheses to blow up. So I'm going to distribute the 5 times d, and again, 5 times negative 3. Don't forget that we want to treat that like a negative sign right now. So 5 times d is 5d. 5 times negative 3, I'm going to already account for my sign as negative 13, minus the 2d. Remember that 2d didn't get affected by the distributing, is equal to, now here is where we could potentially make a mistake. We should have enough experience by now to know that if we tried to add 4 plus 2 in front of the parentheses over here, we would be putting addition before multiplying, and order of operations would not be followed. So to do it right, we only want to focus on the distributing of the number directly outside the parentheses, which is that positive 2. So we'll have 2 times d and 2 times 1. So the 4 is not affected, so we'll say 4. And positive 2 times d is going to give me plus 2d. And positive 2 times positive 1 is going to give me plus 2. So we did the distributive property here. Here's my step 1 of using the distributive property. But we're not finished. We want to continue seeing if there's an opportunity to simplify by way of combining like terms. And we should see on the left side, there are like terms with the variable 5d. Don't forget to put a box around the other term. It's negative 2d. And that's going to give us 5 plus negative 2 is 3d minus 15 is equal to, and I'm going to see if there's any opportunity. There may or may not be, but if there is an opportunity to combine on the right side, I will do so. And I can see the 4 and the positive 2. Those are like terms, not as variable terms this time, but as you should know, as constant terms. So when I write this, there's either order, but I like to start with the variable term. I will say 2d, and then 4 plus 2 will give me plus 6. I could have said 6 plus 2d, but I just like my variable term to always be first. Okay, so that is my combining of like terms. That's actually, I probably should have done all this in blue, because that's my combining like terms. And together, those make up step number 1. Okay, so together, those make up step number 1. So we have all of our simplifying taken care of. Now notice what's unique about this, and we've seen this before, is that we now have a variable term and a constant term on the left is equal to a variable term and a constant term on the right. So there's any number of steps I can do here, but what I'm going to do, just sticking to what I like to do, is to move the lower valued variable term first. So when I look at my variable terms, on the left side I have a 3D, on the right side I have a 2D. Which one's lower? 2D. Okay, so that's going to be the one that we're going to have to send over by way of adding or subtracting to go join its partner on the other side, the 3D. So how are we going to do that? We're going to subtract 2D on both sides. That makes the 2Ds cancel on the right-hand side. And on the right, let's see, 3D minus 2D, I like that. D minus 15 is equal to, the only thing remaining on the right is equal to 6. Now from here, I take another look, and I'm not fully isolated. Well, I've started the process of getting isolated, but now I still have a variable and constant on the left. But we're heading in the right direction because I have only a constant on the right. So what we can do from here is to move this constant over to the other side. Well, take a look. It says D minus 15. What's the opposite of subtracting 15? We'll add 15 to both sides. That's going to make the 15s cancel, and the D is going to come down. And if we take a close look, 6 plus 15 should give us 21. So we should get a final solution of D equals 21, because as I look, so that was my step 2. So all of this, whoops, let's go back. All of this was step 1. By distributing, combining like terms, all of this was step 2, right there, isolating the variable. And when we get to the bottom, we already have 1D, so there is no solving to do. There's no coefficient that we have to undo by dividing. So we're all done here. So our final solution should be D equals 21.